right, my friends, let's take a look. This a sub n notation is typically what we use for basically a function rule where you can use it to generate terms of a sequence. It's kind of like f of n, essentially. And so just to kind of make sure you're clear with some notation, a sub n means the nth term. And so if you let n be a 1, then what would a sub 1 mean? So it would mean the first term. Anyway, so using the rule, just letting n be 1, you'd get a sub 1 is 1/2. The second term, which could be called a sub 2, that would be the quantity 1/2 squared or 1/4. A sub 3 would be 1/2 cubed. Oops. Which would be 1/8. A sub 4 would be 1/2 to the 4th, etc. So anyway, so they basically are just asking you to graph that. Let's see, how do I want to do this? I think I'm just going to put 1/2 here. Anyway, okay, so let's see, put 1 in, we got 1/2. Put 2 in, we got half of that. Put 3 in, we got half of that. Put 4 in, put 5 in, etc. Okay, so here is a picture of the sequence. Now, our job is to fight the urge to do this, right? Right? And so, yeah, so sequences are really just the list of terms. It wouldn't include the values. It wouldn't include these guys. I hope that makes sense. It's just what you'd get when you put in this case, these natural numbers. Okay. All right. So here is a graph of the sequence. And so hopefully you're comfortable with generating terms, just using a function rule, using the sequence notation, and then looking at it in a picture form as well. Now, some vocabulary that I want to throw in. So you can see the next thing on the list after generating terms is determining whether a sequence converges or diverges. And my friends, this vocabulary is a big deal in chapter 8, okay? And it actually is the same as what it was in chapter 7. So let me remind you. So we would say a sequence converges, a sequence converges if the terms approach a finite value. And that is very kind of a layman's terms way of saying that. And so to be more mathy, we would say, let's see, we'll say, how do I want to word this? Let L be a real number. And since it's a real number, it would be finite. We would say if the limit as n approaches infinity of a sub n equals L. Okay, so like here, what would you say the limit as n goes to infinity of this, if we were to keep going, right, on this list, what would you say the value of the terms is approaching? And I'd hope you'd see it's approaching 0. So the L value in this example would be 0, which is finite, real and finite. Anyway, so if that's true, then we say sequence converges to L. There we go. Okay. So this is somewhat important. Okay. So just to make sure that we follow up on what that means here, in this example 1, let's just point out that if you were to take the limit as n approaches infinity of the way that the terms were defined, so 1/2 to the n, what would you get? Would you get something real and finite, right? And so, you know, you could say it just equals 0 if that makes sense to you, or you could kind of distribute the nth power. So 1 to the n is 1, and then 2 to the n. And so it's pretty clear that your bottom number approaches infinity, and so you'd end up with 0. And so we would conclude that the terms converge to 0. The terms of the sequence, oops. Converge to 0. There we go. Okay. And just like in the past, if a sequence does not converge, then we would say that it diverges. There you go. All right, my friends, I hope this is making sense. All right, let's move on to example 2. Let's have you write the first 5 terms and determine whether each sequence converges or diverges. See how it goes, and check in with me in the next video.